Welcome, Hornets, and thank you for joining me today. Today, we're going to be taking a look at how do we graph polar coordinates. And one of the things that we have to remember when we're doing this is that we are on a circular plane. And we also know that vertical angles are congruent. So I'm just going to go ahead and draw a circular plane with a hex grid right in the middle, or a crosshairs, so I can have my circle there. And you'll notice that I have this circle, and polar graphing has concentric circles in it. If you recall, we talked about that. So if we're trying to make our polar grid looks something like this. Now, it's not perfect. After all, if we wanted a polar grid, we could always come up with one and find one that's already printed for us. You'll notice here's an example of a nice printed grid. There are lots of polar graphing paper that is out there. You can always download something from the internet in order to do it. But I just want you to be aware. Now we're going to take a point, and I'm going to go ahead and take a point, 1, 2, 3, 4, and I'm going to say that it's at 270 degrees. We're going to put our point right down there. This point is now 270 degrees. Now the way we got to this point is we went starting in standard position. That's starting on our axis right here at theta equals 0 degrees. We're going counterclockwise around until we reach 270. And then we find our length of 4. Notice, because we have a length of 4 and have gone through a terminal has gone through 270 degrees, it identifies the location of the point. But I want you to notice that I can also get to this exact same point by going clockwise. And if I go clockwise, I have a length of 4 having traveled negative 90 degrees. So here's another example and another one of our 3 possibilities. Let's just keep going. Well, we know that if we reflect through the pole, it becomes an opposite radius. So this point right here is negative 4, and I'm looking at the 270 degrees. So I'm going through the 270 degrees to here to get to 4, and then reflecting. Okay? And you'll notice that this has a 90-degree angle. So to get up here, I'm going 90 degrees and then reflecting. So that's an option. We also have going completely around at negative 270 degrees, and I would get it again. So negative 4, negative 270 degrees. And these are the 4 coordinates that represent this point right down here. Now let's try another one. This time, let's take our graph, and I'm going to go ahead and I'm going to put my point at, let's say 30 degrees. Okay. Right there. 30 degrees. Well, notice that it doesn't matter whether I go left or right. I'm always at 0 degrees. I can't really do much about it, but I can find my reflection over here. And the reflection is going to be at negative 3. And now you'll notice I can either do pi, let's do 180 degrees negative, or I have negative 3 going 180 degrees. And you'll notice I now have my 2 options getting to this point. Now, getting to this point doesn't matter whether I go clockwise or counterclockwise, I'm going to the same place. Okay? And this one has only 3 representations. Let's go ahead and take a look at another polar graph. This time let's use radians. And let's locate 19 pi over 12. And let's just make sure that's 7. So it's a little bit over on this side here. And we have a length of 1. You notice I just found 19 pi over 12 with a length of 1, which makes 1 19 pi over 12. Well, if I go in the other direction, I'm going to find 1, and I need to get to 24 pi over 12, right? You'll notice that's 5 pi over 12 away. So minus 5 pi over 12. I'm now going to shoot it up, and we're now going to find the opposites. I'm going to go up this way. Now keep in mind that reference angles are congruent, so this is 5 pi over 12. Looking at negative 1. And I'm now looking at what is the remnants. So you'll notice if I go this direction, and I know that this angle is already 5 pi over 12, being vertical angles are congruent, I can work with my pi minus that 5 pi over 12, and it will give me 7 pi over 12. And you'll notice now I found my point going counterclockwise. We're now going to get to the same place counterclockwise. That means I'm going this direction. And let's just make sure. So I'm going to take away 24. From 24, I have 7. That's going to give me negative 17 pi over 12. And I now have all of my representations. Notice this adds up to 24. Notice this adds up to 24. See how they add up to 24 when you take their absolute values. This is finding our 4 points that are represented in r theta. And this was our goal. Now keep in mind that I do have other options of how we could look at it. For example, if I have r theta and r is a positive value, then I'm going to find my second point as r comma theta minus pi over 2. Notice that's what we did here. If I have 19 pi over 12 and I have my positive, I'm saying take away 24 pi over 12 from the 19 pi over 12, and you'll notice I get the negative 5 pi over 12 that I used. Okay? When I'm looking at the negative, when I'm dealing with the negative r, and I have a theta, I'm going to go negative r theta minus 2 pi. Now keep in mind, it can't be beyond 2 pi. Okay? So let's just say I have negative r, 7 pi over 12. I'm going to go, and I'm going to take 7 pi over 12, and I'm going to subtract 24 pi over 12, and I'm going to be left with 17 pi over 12, and it's a negative. Let me make sure that negative is clear. Negative 17 pi over 12, which is what I got. Okay. So just be aware that I am using formulas that are given in the book, and I'm following that basic relationship. But if I have r theta, I'm looking at r comma theta minus 2 pi. If I have a negative r theta, I'm looking at negative r theta minus 2 pi again, yet positive r pi plus theta, or r theta minus pi. This will give me all 4 representations. Another way of looking at it, a little bit closer to what the book shows, and that's this. If I have r theta, just take that theta and add 2 pi, or subtract 2 pi. I would add 2 pi if I'm looking at something that is a negative theta, and I would subtract 2 pi if I'm looking at something that is greater than 0 pi. Okay. Here we have pi plus theta plus pi. This n is simply some integer, and it's giving me even values versus odd values. So here we're talking about odd powers of pi, or odd values of pi, 1, 3, 5, 7, etc. Whereas this is 2, 4, 6, 8. Okay. Now this is graphing polar points. It isn't easy. It does take time, and it requires practice. Okay? Let's do one more, and then we're going to call it quits on this lesson. We're going to take a look at 3, 13 pi over 12. All right, so the first answer has to be 13, and I'm now going to take 13 pi over 12, and I'm going to subtract 2 pi. That's going to give me 11 pi over 12, and it will be a negative. Then I'm going to project it, and it's going to become a negative 3. And as it's a negative 3, the reference angle, and keep in mind, I want to know where it is, so let's just think about it. 13 pi over 12 is down here, right? It's got a pi over 12 reference angle, so it's going to be coming over here, and it's now at pi over 12, the reference angle. Then I'm going to do negative 3, and I'm going to use negative 23 pi over 12. See how these add up to 24? These opposites add up to 24 for their absolute values. And that's my goal. Find the 4 representations of our polar coordinate that is given. And that's what we're trying to do. All right. I hope this helped. If it did, please remember to click like. If you have comments or concerns, please remember to let me know, and I will do my best to improve my video. Thank you very much, everybody. Please have a very good and safe evening and a wonderful day. Cheers. Bye-bye now.